Okay, so here we're going to look at a different approach to determining the convergence of sequences. Now, we're going to do that by looking at the growth rates of sequences. So here is a theorem about sequences. So it states that the following sequences are ordered according to increasing growth rates as n goes to infinity, right? So again, right, we're dealing with large values for n, right? As we saw in the previous video, right, we looked at initially maybe we thought a sequence had a certain behavior, but once we got further out, we saw that the behavior kind of was established, right? It kind of stabilized. Okay, so that's what we are focusing on here, right? We're focusing on really large values for n. Right? And what this theorem is telling me that if a sub n appears before b sub n, right? So a sub n appears sometime before, right? If this is an a sub n, a sequence of this type, b sub n is somewhere to the right of it. All right. If that is true, then the limit of a sub n over b sub n always goes to 0, right? So the growth rate in the denominator is just it's bigger. Right? Let's say much bigger. It does become much bigger. So it dominates and it goes to 0. And then vice versa, right? If b sub n in the numerator appears after a sub n, right, somewhere on this side, then if it's in the numerator, then the growth rate is bigger in the numerator, and that makes the sequence go to 0. All right, so now it really comes down to just remembering this sequence, this ordered inequality here to determine something like, let's say, here we wanted to, and also one thing I should make note here, right, is that the ordering here applies when P, Q, R, S are positive real numbers, and B is bigger than 1. Okay? All right, so here, for example, let's say we wanted to, well, let's look at a few of these, right? So let's take a look at the convergence here of the following sequence. ln n to the 10th over 0.00001n. All right, and I want to determine whether this converges or not. All right, so just kind of looking at this. Now, one thing to realize is that this ordering can be established through the use of L'Hopital's rule, right? All of it except for the ones out here, right? That n factorial, right? So we just assume that's kind of the place that it lies in, right? But these other ones we can prove through the use of the L'Hopital's rule. But here, we'll just use the ordering already given to us, right? And then to realize that, okay, now how do I order these here, and what does that tell me about the convergence? Right, now one thing to realize is that this n to the 10th is not the same as LQ to the n, right? And here, what we realize is that a power in a logarithm is really just a coefficient. All right, and here, through limit laws, really, we can see that the constants really are not going to play a part in the convergence or divergence. All right, those are real valued constants. I can essentially ignore them and really focus on this right here. All right, and seeing that n, right, n to the p, right, p here being 1, positive real number, right? So that one appears after L of n's, the natural log of n, right? So that's telling me that the growth is happening much faster in the denominator, right? So this means that here, if I were to find what is the limit of my sequence as n goes to infinity of 10 ln of n, 0.00001n, since it is growing faster in the denominator, that goes to 0, right? And it converges. All right, now let's take a look here at another example here. All right, let's say something like n factorial over 10 to the n. Okay, so here we take a look again at the ordering here, and 10 to the n, something like this. Oh, sorry, like this. It's kind of an exponential, right? So it grows really fast, right? An exponential grows really fast, but we see that actually the factorial grows faster. All right, so the growth rate is faster in the numerator, so this drives this whole sequence to go to infinity, or in other words, it diverges. All right, so really what it comes down to when evaluating this is really we want to determine where is it growing faster, right? Numerator or denominator, right? And that'll lead us to the result that we are trying to establish, right?